everyone, my name is Dr. Courtney Chris and I am a food scientist at Mississippi State University. Today I will be showing you some cool food science experiments that you can do even at home. Food scientists have lots of fun with food and we make a lot of cool products. Thank you so much for joining Science Fest. We hope that you have learned something fun today. We'll be talking about tie-dye milk. You'll be amazed as you watch the forces of surface tension at work in this colorful experiment. So what you'll need is a shallow dish or plate, a small cup or bowl for water and dish detergent. You'll need milk, preferably whole milk because it has more fat in it, a cotton swab, and liquid food coloring. The liquid is better than the gel. So what we're going to do first is we're going to add enough milk to cover the bottom of the plate. Next, we are going to add some food coloring. Next, you're going to grab the water and the dish detergent that's already been mixed. You're going to dip the cotton swab in the detergent liquid, and then you're going to place it on the food coloring dots and see what magic happens with tie-dye. So imagine that the surface of liquids is stretched, elastic skin like the surface of a balloon of air. The scientific name for the way the skin of a liquid holds together is called surface tension. When the skin of the liquid is broken by the detergent, food coloring and milk move and swirl around in interesting patterns on the milk surface, just like tie-dye. Milk has fats in it. The soap causes the milk and fats to move, as we see. The food coloring shows how the soap and the detergent pushes the fat and milk around, creating a really unique and fun experiment at home. We're going to make disco dancing spaghetti. So what you'll need is a clear drinking glass with water about 3/4 of the way full. I've already poured it in. You'll need 3 teaspoons of baking soda, food coloring, vinegar, 5 tablespoons white vinegar, and 10 pieces of broken up angel hair pasta. So as I already mentioned, I filled the glass 3/4 full with water. Next, I'm going to add the baking soda. Then I'm going to add 1 drop of food coloring. And now I'm going to stir it in. I've already broken the pasta up and I'm going to put the pieces in the glass. Next, I'm going to add the vinegar. Here you can see the pasta dancing at the top. So pasta sinks in water. Adding baking soda and vinegar makes carbon dioxide bubbles. The bubbles stick to the pasta, which makes the pasta rise and fall. going to talk a little bit about how pH affects food. Here I have 3 samples: orange juice, lemonade, and lemon juice. These products most likely have different pH values. pH is really important in food products because it helps us determine safety of products and shelf life of products, among other things. So a pH scale, the lower the number, the more acid the product has. Neutral pH is around 7. Below 7 is more acidic as you go down, and above 7 is more basic as you go up. So any guesses as to which of these might be lower, have a lower pH and might be more acidic? I prepared these already, but I also have some baking soda that I'm going to pour in, and you guys can see the reaction and tell me which one you think has more acidity and a lower pH. First, orange juice. Next, I'm going to do lemonade. Hopefully you can hear the fizz. Last, I'm going to do lemon juice. Hopefully you can see the difference in these 3 products by the amount of bubbles or fizz, carbon dioxide, that it produces. You can see our lemon juice is starting to get closer to the camera as it moves up. Our orange juice looked pretty good, and our lemonade really isn't having a whole lot of reaction. It does have some fizz, so there's some acidity present. Most likely this has a lot more water in it than the other 2 products. So our lemon juice continues to increase towards the top of the jar. Orange juice is still okay. Generally, lemon juice has a pH pretty low, probably around 2. Our orange juice is next with a lower pH, more acidity. And then our lemonade doesn't have as much acidity, but as I mentioned, it probably has a good bit of water in it, making it more towards the neutral side of these 3, but still acidic because it produced some fizz. Thanks so much for joining in today.